Good morning, everyone. I am Amit Monga. I am here to present my research paper on FCTFANet, a fused CNN transformer feature aggregator network for image restoration. My paper ID is NTIRE048. Here is the outline of my work. First, I start with the introduction, then we'll discuss the major contribution, proposed architecture, the results on different restoration work as image deraining, dehaging, denoising, and low light enhancement. We will study the ablation and then we'll conclude with the conclusion. So the major contribution of my research is we are proposing a fused CNN transformer based image restoration architecture that leverages the advantages of both CNN and transformer. The feature extracted from the CNN and transformer network at different levels are fused together in an effective way by stacking and utilizing a softmax operation on global average pool CNN and transformer features. We are using a novel feature aggregator which will capture the multi-level features from the fused features of CNN and transformer block, which will preserve the fine-grained details as well as the high-level contextual information. Extensive experiment on image deraining, denoising, dehaging, and low light enhancement datasets demonstrate the superior performance than state-of-the-art CNN and transformer-based image restoration architecture. So this is the architecture we are proposing. So the input image, which is a degraded image, will be passed first to the convolution layer. The feature extracted from the convolution layer simultaneously passed to the transformer and CNN block. The features extracted further from the transformer and CNN block will be fused together with the help of a fusion module. And similarly, at different levels, the same process will be continued. The features will be fused together, and finally, all the fused features will be aggregated together with the help of a feature aggregated module. The final features will be passed through an output convolution layer, and we will get the restored image. For CNN block, we had used this architecture. The input features will be layer normalized, will be passed through the 1x1 convolution, and then will be processed with the help of 1x1 convolution and 3x3 convolution layer. And simple gating mechanism will be used to mix the features, and the features will be concatenated together and will be passed through a simple attention mechanism. And finally, we will get the processed feature map from the CNN block. For transformer, we had used the multi-head attention module, and this is the feed-forward network for this. For fusion of this transformer features and CNN block, we had the fusion module, which we are proposing is this one. The input features will be global average pooled and will be converted to a vector, and that will be stacked together and will be passed through a softmax operation. The importance vector will be will be get out with the help of zeta 1 and zeta 2 and will be multiplied with the help of the input features of the transformer and CNN block, and then finally it will be added together and we will get the fused feature map. So the different level fusion feature map as F1, F2, F3 will be added together with the help of feature aggregator. For feature aggregation, we had used this module, which is where the features first will be concatenated together, and then 1x1 convolution will be used to make the dimensionality of channels lower. Then finally, those features map will be processed with the help of 1x1 convolution, 3x3 convolution, and 1x1 convolution as a residual network, and we will get the aggregated fused feature map. The results we have used the different image restoration task as image deraining, dehazing, denoising, and low light enhancement. For image deraining, the qualitative and quantitative analysis is shown. Uh, we had we had tested with respect to the PSNR and SSIM metrics. The different test data sets used are test 100, rain 100H, rain 100L, test 1200, and we are getting the superior performance with respect to the previous CNN and transformer uh, state-of-the-art architecture. For image dehaging, uh, you can see the visual comparison as well as the analytical comparison with respect to the previous state-of-the-art network. Our FCTFANet is getting the superior performance with respect to the NH-Haze dataset, TENS-Haze, and RESIDE datasets. Our parameter is also low with respect to the transformer architecture, but somewhat in the range with respect to the CNN architecture. For image denoising task, we had used the BSD 68 and Urban 100 dataset with different standard deviation Gaussian noise is 15, 25, and 50, and we are getting the improved performance with respect to the previously proposed state-of-the-art architecture. For low light enhancement tasks, again we had used the LOL dataset, and our architecture is improving with respect to the PSNR and SSIM values. We had done some ablation studies also to check the efficacy. The first we had used the fusion block efficacy. Uh, in this, in, beside using the fusion module, we had directly added the features map from the CNN and transformer block, and we had checked the performance with respect to the test 100, NH, and LOL dataset. Uh, we had noticed that with fusion module, our PSNR and SSIM values are improving instead of direct addition. For loss function, we had used the L spatial and L frequency loss together. We had checked the performance with only one loss, which is spatial loss, and we are getting the improved results by adding the frequency loss. For checking the efficacy of feature aggregator module, uh, first we had taken the only the last stage output, and then we had used the all level outputs with the help of feature aggregator, and we had noticed that by using the different level features map with the help with feature aggregator, we are getting the improved results. So the conclusion is we are proposing the fused CNN transformer architecture, which has a feature aggregator. It leverages the strength of both CNN and transformer to extract the local and global features, and hence improving the restoration process. The proposed FCT-FANet architecture not only overcome the computational overhead associated with transformer, but also exhibit superior performance compared to standalone CNN and transformer models over the different tasks as image deraining, dehazing, denoising, and low light enhancement. Thank you.